Hey everyone, and welcome. Today, we're diving into some technology that is, well, literally mind-bending. The brand new Galaxy S26 has a feature that solves a problem we've all faced, and it's not just some simple software trick. No, this is about physically controlling the path of light itself. Let's get into it.
So here's our game plan. We'll kick things off with a problem I think we all know too well: prying eyes. Then we'll look at why the old solutions just don't cut it before we get to the really cool part: this incredible orchestra of hardware that makes the new system tick. We'll explore the actual magic of how it bends light, and then wrap up with why this all adds up to privacy without any of the usual compromises.
All right, I want you to picture this. You're on a crowded train, maybe in a coffee shop line or just waiting somewhere. You pull out your phone to check something important, your bank balance, a private conversation, and you get that prickly feeling on the back of your neck, the feeling that you're being watched.
Right? It's that super uncomfortable glance over your shoulder, what we call shoulder surfing. All of a sudden, your personal, private screen feels like a public billboard. It's a universal problem in our world today, and it's exactly what this new technology is designed to completely eliminate.
Now, I know what some of you might be thinking. Hey, I have a privacy filter for that. And, that's a fair point. But we need to talk about why those old solutions are, well, fundamentally flawed. They're really more of a band-aid than an actual cure. So this is the old way, right? It's basically just a dark software filter that you slap on top of your screen. The big problem? It makes the screen dim and kind of hard to read for everybody, including you. And let's be real, a determined snooper can often just tilt their head, or you can crank up the brightness, and the whole thing is useless. It's not real security.
And this comparison just lays it all out, doesn't it? On the left, you have software dimming, a flimsy, easily tricked attempt at privacy. But on the right, that's a true hardware solution. This isn't just about making the screen darker, it's about physically taking control of light at a microscopic level, so the screen is perfectly clear for you, but completely black for anyone peeking from the side.
Okay, so how in the world does this actually work? Well, it's not just one thing. The best way to think about it is like a high-tech orchestra, where four major players have to work in absolute perfect harmony. The whole system is called Flex Magic Pixel.
So, here are the musicians in our little orchestra. We have the AP, which is the main processor, the GPU for graphics, the DDI, the display driver, and of course, the display panel itself. Each one has a super specific, absolutely critical job to do. So let's break down what each one brings to the stage.
Let's start with the conductor of this whole symphony, the application processor, or AP. You can think of it as the brains of the entire operation. It doesn't control the light directly, but it's the one that decides when that privacy shield needs to go up. So, check this out. It uses a super smart AI security agent, powered by its neural processing unit, that is constantly aware of what you're doing. Are you opening a banking app? Typing in a password? The moment it senses this need for security, the CPU, our conductor, sends the command to the rest of the orchestra. Activate privacy mode, now. All right, next up in the orchestra, we have our specialist, the GPU, or the Graphics Processing Unit. Its job is to handle all the visuals with incredible surgical precision. And this is where it gets insanely cool. The GPU can do something called zonal rendering. What that means is it doesn't have to black out the entire screen. It can secure just a single password field or just a notification banner that pops up while the rest of your screen stays perfectly normal for you to see. That's targeted, efficient privacy. Okay, now we get to meet the real virtuoso, the unsung hero of this whole operation, the display driver IC, or DDI. If the CPU is the conductor waving the baton, the DDI is the lead violinist, playing this impossibly complex solo at lightning speed. It takes the high-level commands and turns them into action, pixel by tiny pixel. So, the order's been given by the conductor. The GPU has picked its target. Now for the main event, the real magic. How does the phone physically bend light to hide the screen from anybody trying to sneak a peek? The secret sauce here is something called the Virtual Refractive Layer, or VRL. Now, this isn't some stick-on film. It's an unbelievably thin layer of specialized liquid crystals that is built right inside the display panel itself. Its entire job is to act like millions and millions of microscopic lenses that can literally steer light on command.
So remember our virtuoso, the DDI? This is where it really shines. It sends these incredibly precise, tiny electrical voltages to every single subpixel. That voltage makes the liquid crystals in the VR snap into a very specific alignment.
This creates a super focused beam of light, almost like a tiny spotlight for each pixel, aimed directly forward at your eyes. Any light trying to escape to the side gets physically blocked, using a cool physics principle called total internal reflection.
So let's just recap that real quick. It's 4 simple steps. First, the DDI sends the signal. Second, the liquid crystals align. Third, the light path is narrowed down. And fourth, the side view is physically blocked. Boom, done. This is pure physics in action, not just a dimming filter.
So, what does all this incredible, frankly futuristic tech actually get you? Well, it means you finally get real, robust privacy, without all those annoying trade-offs and compromises we've just had to put up with for years.
First, and this is the big one for you, the user, your own view is absolutely perfect. There's a smart system called LEED 2.0 that instantly corrects for any potential dimming or color shifts. This means the view from the front stays at 100% brightness and perfect color accuracy. No more squinting at your own private screen.
Second, you think all this tech would make the phone a brick, right? Nope. Because this virtual refractive layer is built directly into the display. It's called an in-cell design. The entire screen module is actually thinner than a regular screen that has one of those clunky stick-on privacy films on top.
And third, it just works. It's totally reliable. You see, when you have all these different high-frequency signals flying around right next to each other, they can interfere, which can cause a flicker. It's kind of like signal crosstalk. But they've engineered this with enhanced shielding and all the connections to keep those signals separate, guaranteeing a rock-solid, stable image.
And finally, the question on everyone's mind. What about the battery? You'd assume all this extra work would be a massive power drain, but no. Through a combination of low-power parts and really smart algorithms, the whole privacy mode is incredibly power efficient, so you can actually use it without constantly worrying about finding a charger.
So, let's bring our orchestra back on stage for one final bow. You have the AP, our conductor, sensing the need for privacy. You have the GPU, our specialist, handling the partial screen rendering and image correction. You have the DDI, our virtuoso, applying that precise voltage. And finally, the panel, the stage itself, physically blocking the light. It is a perfect symphony of technology.
And this really leaves us with a fascinating thought to chew on. For so long, digital privacy has been this abstract thing, right? It's been about software, encryption, passwords, but now the physical hardware, the very glass in our hands, is an active guardian of our secrets. If our screens can literally command photons of light to decide who gets to see them, it really makes you wonder, what's next for the future of on-device privacy? What comes after this?